So let's do this. Let's draw another angle. Let's just talk about a couple other things. We talked about the sides of the angle. This is not that real big of a deal. But watch, what if I had a point between, oh, I kept it in, between these two sides right here. We say that this point is, what's that? Yeah, it's in between. It's not on the rays itself, okay? It's actually somewhere in between them, okay? We say, what do you think? That's, we could say inside, or what do you think a big fancy math word would be? Instead of inside the angles, we say it's in the,
Intersect.
Still didn't get it? How about that? Okay, good. It's the interior, okay? It's the interior of the angle. So this point A, I would say, is the interior of this angle. You follow me? Of course, this isn't brain surgery. What's that going to be?
Exterior.
Yeah, that would be in the exterior of the angle. All right, no big deal. We're not. That's really not super important, but it's good to know because we'll refer to that every once in a while. Let's see what we want to talk about. If we're going to measure an angle, now, like I just said, I don't have a protractor online here. I did, but my internet's broken. But if I wanted to measure, like from here to here, what do we measure that in? Do we measure it in inches and centimeters, Kenny? Kenny, eyes open, please. What do you think we measure this in? In what? In degrees, okay? You've probably done that before. Who's used a protractor before? Yeah, you probably did in middle school and elementary school. Use protractors, figure out how many degrees it is. All right, my guess, this would probably be about, I don't know, 30, maybe 35 degrees. That would be a complete guess. I don't have a protractor online, so it's hard to tell you how to use it, but I think you guys are okay with that. It's on the bottom of page 37, if you want to look in your books. And it talks about how to use a protractor. I'm not going to make you get a protractor. All right, so don't worry about it. If you have one, that's great. If not, you don't have to get one. But that's kind of what we're doing there. All right, let's go on to something else. Yeah. What, this hasn't been exciting enough for you? Let's do this. Let's change colors here. All right, let's name special types of angles now. What if you had that angle right there? Now, I bet you guys have learned this stuff before. But what do you think this angle is right here?
Right angle. 90.
Looks like it, doesn't it?
Oh, wait.
It is? How do you know?
You don't.
That's right. You don't know it's a 90-degree angle. You can't just say that's a 90-degree angle, can you? Kenny? Come on now. So you can't say it's a right angle unless you see what?
A box.
Yeah, the little box. Okay, so we're going to put a little box right there. With that box, now what kind of angle is that? That's a right angle, or 90 degrees. Okay, so we call it a right angle. And how many degrees is a right angle? It's exactly 90 degrees. All right, so that's a right angle. We good with that? Let's draw another one. Let's go green. Let's do this angle. Oops. Oh, what do you think you call that?
Acute.
Right, it's an acute angle. Doesn't it look cute? Yeah, that's right. It's less than 90 degrees. That's how we're going to write it. Technically, they would say it's between 0 and 90 degrees, but I'm okay saying it's less than 90 degrees. All right, so an acute angle is less than 90 degrees. Again, where would 90 degrees go? It would go straight up and down, wouldn't it? See how it's smaller? Okay, it gets closer and closer to this line right here, so it's less than 90 degrees. And again, this is probably not all new to you. You've probably seen this stuff before. What do you think the next one's going to be?
Obtuse.
Yeah, obtuse. And what kind of angle do you think?
90.
Right. We call that obtuse angle, and it's greater than 90. Technically, they say it's between 90 and 180, but I'm okay if you just remember it's greater than 90 degrees. All right, so that's an obtuse angle. You see? It goes to 90 and it goes a little bit more, doesn't it? Because 90 would be right there, wouldn't it? Okay, so that's an obtuse angle. We good with that? We'll be referring to those words quite a bit. And let's do a little bit more. Let's do this. How much time do I have?
Yeah.
11:22. Wow, I got no time then, do I? Let's talk about this real quick. Okay, don't leave if the bell rings. Just give me a second here, okay? Watch. If I had an angle right here, now watch this. You watching carefully? What if I split this angle exactly in half? That looks in half. I'm just eyeballing it right now, but let's pretend that's in half right there. So angle 1, if it's split in half, tell me something about angle 1 and angle 2. They're different? They're the same, right? They're the same. So angle 1, watch what I did. I put a little arc right there. That little arc means those two angles are exactly the same. And I also call this, now I didn't put the arrows here, but this thing, if it splits this in half, we call this an angle bisector. It doesn't just intersect it, it just doesn't split it into two angles, it bisects it. What does the prefix bi mean? Two, bicycle, two wheels, right? So it's a bisector, it splits it into two equal angles. That's an angle bisector. Make sense? All right. Here's another thing. What if these two angles are equal to each other? In geometry, we'll do this little symbol. Anybody seen that before? It's an equal sign with a little. Let's do a little bit bigger. Equal sign. Well, if it was just one squiggle, it would be about or approximately. We in geometry, don't leave yet. We use the word congruent. All right. So if two angles are equal to each other, this is the symbol that we use. We'll be using that all year, and it's called congruent. All right. I'm going to give you a little worksheet. And I think I've covered enough for you to be able to do that worksheet.